So picture this. It's August 1977, and a computer at Ohio State University prints out a sequence of 6 characters. Just 6. EQUJ5.
Right, which, to a layman, it just looks like a total typo.
Exactly. A total glitch.
Mm-hmm.
But to the astronomer reading that specific printout, I mean, it was a sound so unnaturally loud and mathematically perfect that it basically threatened to alter the course of human history.
Oh, absolutely.
So welcome to this deep dive. Today, we're opening up the source files on a really fascinating document. It's called 72 Seconds of Cosmic Silence.
Yeah, and our mission here is to investigate, well, probably the most haunting mystery in the history of radio astronomy, the WOW signal.
It really is.
Because it's a piece of history that forces us to reevaluate how we search for intelligence out there. We live in this era of constant noise and just total information overload.
Oh, for sure.
But this investigation is fundamentally about the profound weight of silence. We are looking at a moment where the universe seemingly spoke up for just over a minute, only to basically never speak again.
Okay, let's unpack this. Because the setting itself is, it's incredibly mundane, which kind of makes the whole anomaly stand out even more.
Yeah, it's late at night, August 15th, 1977.
At the Ohio State University Radio Observatory. We have an astronomer, and he's just reviewing actual physical pages of continuous computer printouts.
Right, from this massive radio telescope known as the Big Ear. And we really have to understand what he's actually looking at on those pages to get why it's so crucial.
It's not a picture of space, right?
Yeah.
It's just numbers.
Yeah, exactly. The Big Ear's computer, it was programmed to measure the intensity of electromagnetic radiation hitting its receivers.
Okay.
And it mapped that intensity using a very specific alphanumeric scale. So the numbers 1 through 9, those represented your normal, low-level cosmic background noise.
Just the ambient static of the universe, basically.
Precisely, the baseline hum of space. And this is where it gets interesting. If the intensity of a signal exceeded that baseline, the computer switched from numbers to letters.
Always.
Yeah, so A represented an intensity 10 times the background noise, B was 11, C was 12, and, well, so on down the alphabet.
So when the astronomer is scanning these columns of mostly 1s, 2s, and the occasional 3, and he suddenly sees 6 EQUJ5 print out in a single column, that U is the peak of the signal.
Exactly, the letter U.
Which means, wait, let me do the math. If A is 10, it was 30 times louder than the normal background radiation of deep space. That is a massive spike.
It's totally massive. It's what we call a 30 sigma event.
A 30 sigma event.
Yeah. In statistical terms, an anomaly that massive simply does not happen by random chance.
Wow.
But the volume wasn't the only thing that made him freeze. It was the physical profile of the signal itself. You see, in the 1970s, researchers working on SETI, the search for extraterrestrial intelligence, they were specifically hunting for narrow-band radio signals.
But hold on, the universe is a loud, violent place, right?
Oh, very loud.
You have quasars, supernovas, colliding black holes. Why couldn't one of those astronomical events just randomly burp out a powerful narrow-band spike?
That's a great question. And it comes down to the fundamental physics of how nature produces energy. Natural cosmic events are chaotic.
Right.
When a star explodes, it doesn't carefully tune its energy. It blasts radiation across an incredibly wide range of frequencies all at once. That's what we call broadband.
Okay, so it's messy.
Extremely messy. Narrowband, on the other hand, requires focus. It requires energy to be artificially constrained and directed into a single tight frequency.
So it's kind of like finding a perfectly typed word in a bowl of alphabet soup.
Yeah.
It clearly stands out against the background radiation.
Yes. Or, to use an audio analogy, it's like listening to the static of a completely untuned radio and suddenly hearing a single, sustained, perfectly tuned piano key just cut right through the white noise.
Oh, wow. Yeah. It's not just loud. It's engineered. It has intent.
That is a perfect way to visualize it. That level of precision is the absolute signature of technology.
Mind-blowing.
It fits the exact structural profile scientists expected an intelligent extraterrestrial communication to have. And that is why the astronomer stared at that paper, took a red pen, drew a circle around 6, EQUJ5, and wrote a single word in the margin.
Wow. Literally, he just wrote wow with an exclamation point.
Yeah, the wow signal.
The moment that sparked 50 years of obsession. But, as I'm looking at the source material here, we have this massive peak at the letter U. And it's flanked by a buildup of 6, E, Q, and then a tapering off at J5.
Right.
The signal lasted exactly 72 seconds.
Ah.
And we know it originated from deep space, somewhere near the constellation Sagittarius, not Earth, not a satellite.
Exactly. Deep space.
But this is where the logistics really start to bother me.
Right.
Wait, if an advanced civilization is beaming a message at us, like going through this monumental effort across thousands of light years, why would they cut it off after exactly 1 minute and 12 seconds? Why 72 seconds? It makes no sense.
You're right. It wouldn't make sense. And the brilliant, really kind of mechanical reason behind this mystery is that it wasn't the signal that stopped. It was us. We moved.
Wait, what do you mean we moved?
Well, to understand this, we have to look at the architecture of the Big Ear telescope itself.
Because it wasn't a traditional telescope, right?
Yeah.
Like the kind you point and steer at a specific star.
Right. The Big Ear was immense. I mean, we're talking the size of 3 football fields.
Oh my gosh.
And it was entirely flat on the ground. It consisted of a flat reflector panel and a curved reflector panel. Because of its massive size and design, it couldn't physically pivot to track an object across the sky.
So it couldn't move at all.
Nope. It was totally fixed. It relied entirely on the rotation of the Earth to scan the heavens.
Ah, okay. So it's like shining a flashlight at a wall, but the wall is standing perfectly still, and the person holding the flashlight is spinning in a slow circle. The beam is only going to illuminate a specific spot on the wall for a brief moment as it sweeps past.
Exactly. The telescope's listening window was incredibly narrow. As the Earth rotated, sweeping that listening window across the sky, it took exactly 72 seconds for a fixed point in deep space to enter the edge of the telescope's range.
And then it slides to the center.
Right. It slides to the center where the signal would reach its maximum intensity, which is that letter U we talked about.
Right, the peak.
And then it exits the range on the other side.
So the sequence 6, EQUJ5, is literally the physical shape of the Earth rotating.
Yes.
It's the signal getting louder as the antenna points more directly at it, and quieter as the planet turns away.
It is the perfect Gaussian profile. The 72 seconds wasn't the length of the alien transmission. It was the absolute maximum amount of time our specific telescope could physically listen to a single coordinate in space.
That dramatically shifts the perspective. The signal itself could have been broadcasting for hours or days or years.
Oh, absolutely.
We just caught a 72-second slice of it as we drifted past. Okay, so we have an incredibly strong, artificially narrow signal originating from a fixed point in deep space.
Yeah.
If the telescope mechanics prove where it came from, the next logical hurdle is the frequency itself. Because you don't just broadcast blindly into the void.
Yeah.
You have to pick a channel.
And the channel they picked, or, well, that this signal was detected on, is where this moves from just a compelling anomaly to a profound scientific mystery.
Here's where it gets really interesting. Because 1420 megahertz is known in astrophysics as the hydrogen line.
Yes, it is.
Let's delve into the mechanics of why that specific number is so crucial, because it's like the emergency broadcast channel of the universe.
I like that. The emergency broadcast channel.
Right, because hydrogen is the most abundant element in the universe. But why does that dictate a radio frequency?
Well, it comes down to quantum mechanics, specifically something called the spin-flip transition.
The spin-flip transition.
Yeah. In a neutral hydrogen atom, you have 1 proton and 1 electron. Occasionally, that electron will just flip its spin state, changing its magnetic alignment.
Okay, I'm with you.
When it does that, it releases a tiny burst of energy, a single photon. And that photon always, without fail, has a wavelength of exactly 21 centimeters.
And that 21 centimeters equates to a frequency of 1420 megahertz.
Precisely.
So the universe is essentially humming with this natural frequency because hydrogen is literally everywhere.
Yes. And because hydrogen is the basic building block of stars, any intelligent species anywhere in the cosmos that has developed astronomy and radio physics, they will naturally study that frequency to map their own galaxy.
Ah, okay. So if you want to get another civilization's attention, you don't just pick a random decimal on the radio dial.
No, you don't.
You deliberately broadcast on the exact frequency.
Yeah.
You know, their scientists are mathematically obligated to be monitoring.
Exactly. It's the most logical meeting point. But there is a secondary, equally vital reason for choosing 1420 megahertz.
Which is?
It sits within a very specific band of the electromagnetic spectrum that radio astronomers call the water hole.
I saw this in the notes, and the logic behind it is just fascinating.
It really is. The galactic background noise, so all the static from cosmic radiation, is remarkably quiet between the frequencies of 1420 megahertz, which is the hydrogen line, and 1662 megahertz, which is the emission line of hydroxyl.
Okay, wait. Hydrogen, which is H, and hydroxyl, which is OH.
Right. And together, they form water, H2O.
So the water hole isn't just a poetic name. It's literally the quietest stretch of the radio spectrum, bounded by the components of water, which is the foundation of life as we know it.
It's the universal gathering place. If an advanced civilization wants to cut through the noise of the galaxy, they would broadcast in the water hole.
That makes total sense.
Right. It requires the least amount of energy to send a clear signal, and it's the most logical place for another water-based, intelligent species to be listening.
The elegance of that is chilling. The WOW signal wasn't just loud, it was placed in the exact theoretical sweet spot that human scientists had predicted an alien beacon would use.
It checks all the boxes.
But if it was perfectly placed, incredibly powerful, and structurally aligned with artificial technology, why isn't it universally accepted as an alien transmission?
Because it failed the most rigorous, unforgiving demand of the scientific method. Repeatability.
Repeatability, right.
Science structurally cannot accept a single data point as proof of a new paradigm, no matter how perfect that data point appears to be.
You can't just run an experiment once,
Yeah.
get a crazy result, and call it a law of physics. You have to be able to do it again.
And they tried. Believe me, they tried. After the signal was discovered, astronomers immediately pointed telescopes back at that exact region near Sagittarius.
Yeah.
They listened for hours, then days, then months, and they got nothing.
Wow.
Absolute silence, no repeat transmission, no recognizable pattern, just the ambient static of the cosmos.
Which creates a massive scientific dead end. We can't prove it was a beacon because it never came back. But nature abhors a vacuum, and so do researchers. So over the years, people have tried to explain it away with alternative theories. I want to push back on some of those, starting with human interference.
Sure.
We've all had the experience of our electronics picking up stray signals. Could it really just be some weird weather bouncing a human radio broadcast back down to the Big Ear? Like a classified military satellite or ground-based radar bouncing off space debris?
What's fascinating here is that it's the first thing researchers investigated, but it fails on a few technical levels.
Oh, really?
Yeah. First, the 1420 megahertz frequency is internationally protected. It is strictly reserved for radio astronomy. No satellites or military communications are legally allowed to broadcast on that channel because it would blind our telescopes.
But even if we assume a rogue satellite or a military glitch broke the rules, does the satellite signal actually look like the WOW signal?
It doesn't. Remember the Gaussian profile we talked about?
A 72-second rise and fall of the signal.
Right. That profile only occurs if a fixed point in deep space is moving steadily across the telescope's field of vision due to the Earth's rotation.
Ah, I see.
A satellite in local orbit moves far too quickly across the sky. It wouldn't produce that perfect, symmetrical 72-second bell curve.
Okay, so it's not local orbit. What about a natural cosmic event? I know some recent theories suggested a passing comet.
Yeah, the comet theory.
The idea being that the comet had a massive cloud of hydrogen gas around it, and as it passed through the telescope's view, it triggered the hydrogen line detection.
The comet theory gained some media traction for sure, but the broader astrophysical community rejected it fairly quickly.
Why is that?
Comets simply do not emit radio waves that are that incredibly strong, nor that narrowly focused. A comet is a messy natural phenomenon.
So it would be broadband again.
Exactly. It
Anyway.
would produce a wider, more erratic frequency profile, not the razor-sharp single-pitch transmission the Big Ear recorded. Furthermore, the telescopes didn't record the signal in their secondary feed horns.
What does that mean?
Well, the Big Ear had two receivers right next to each other. If a large, diffuse comet cloud was passing through the area, it should have triggered both. It only hit one.
So we are stuck in a frustrating limbo. The signal is too artificially pristine to be a comet, but too deeply isolated in space to be a human satellite.
Right.
Yet, without a second detection, we can never definitively prove it was extraterrestrial.
And that scientific dead end is exactly what creates the existential weight of this mystery. We are forced to live with a what if.
Yeah.
When hard science reaches the limit of what it can prove, we are left confronting the philosophical implications of what the data suggests.
Because if we assume, just for a moment, that the data was exactly what appeared to be an artificial beacon from another world, it fundamentally alters our perspective on our place in the cosmic timeline.
It really does. The universe isn't just large, it is ancient. We are dealing with vast, terrifying stretches of time and distance.
So what does this all mean for you and me? For the listener sitting at home?
Well, statistically, the existence of intelligent life elsewhere in the billions of galaxies and trillions of stars is highly probable. But the brutal reality of cosmic mathematics is that civilizations do not last forever.
Right.
They rise, they develop the capability to broadcast into the void, and eventually they fall. And all of that might happen over the course of 10,000 or maybe 100,000 years.
Which is basically a rounding error in a universe that is nearly 14 billion years old.
Exactly. So even if the galaxy has hosted thousands of intelligent species, the chances of two civilizations overlapping in time, one broadcasting while the other is technologically capable of listening, are incredibly slim.
They are ships passing in the night.
Yes. The WOW signal has become the ultimate symbol of that cosmic loneliness. If it was a message, it wasn't an invasion fleet or a galactic encyclopedia.
It was simply a beacon, a mathematical lighthouse saying, "We are here."
And what's truly haunting is realizing the mechanics behind that lighthouse. Our source material asserts a very real possibility that civilization might not have sent a single one-off pulse.
Oh, right, because why would you?
Exactly. They could have been transmitting that beacon continuously, sweeping it across the galaxy for years, decades.
Sweeping a beam of energy across millions of star systems, hoping someone, somewhere, had an antenna pointed in the right direction.
Right. And out of those decades of continuous transmission, humanity simply happened to catch a fleeting 72 seconds.
We caught it just long enough for our planet to rotate the Big Ear telescope through the beam, print out a sequence of numbers and letters, and then spin away into the dark.
And as the Earth kept turning, the beam passed us by. Even today, astronomers have not given up. We have massive modern arrays utilizing artificial intelligence to monitor millions of frequencies simultaneously.
Looking at those exact coordinates in Sagittarius.
Yes, searching the exact coordinates where the WOW signal originated. But the result has been absolute silence.
Which leaves us with a truly sobering realization. If another civilization genuinely sent that transmission, pouring unimaginable energy into the cosmos to declare their existence,
They will likely never know.
they will likely never know that it washed up on a small blue planet, printed out on a stack of paper, and was circled in red pen by a solitary astronomer working the night shift.
They cast their voice into the infinite, completely unaware of whether anyone was listening.
Because humanity may have heard them only once.
Yeah.
Well, on that profound note, I want to thank you for joining us on this deep dive. We've traced the path of a single unexplained spike in a data printout, unraveling the mechanics of radio astronomy, the physics of the hydrogen line, and the existential tragedy of cosmic timelines.
It is a powerful reminder of the limits of our own perception. We are a young species, looking through very narrow windows into an unimaginably vast dark.
We are. But before we sign off, I want to leave you with one final realization to mull over regarding our perception.
Okay.
We spent this time dissecting the 72 seconds we managed to catch. But consider the pure geometry of our rotating planet. The Big Ear telescope, massive as it was, only observed about 1/1,000,000th of the sky at any given moment.
A tiny fraction of a fraction.
Exactly. So I want you to think about the pure, terrifying mathematical luck of that alignment. If the only reason we caught the WOW signal was because our planet happened to be rotated at the exact right angle, pointing a single radio dish at a specific 1/1,000,000th of the sky,
Oh, wow.
that means for every one WOW signal we miraculously catch, there could be 1,000,000 identical beacons hitting the dark side of the Earth, bouncing off our atmosphere entirely unnoticed simply because we were facing the wrong way on a random Tuesday.
The sky could be full of them, and we simply lack the capability to see the full picture.
We might be swimming in a sea of signals deaf to almost all of it. We'll never know. But we'll keep listening, keep analyzing the noise, and keep building better windows into the dark. Keep your curiosity alive, and remember that sometimes the most profound discoveries aren't loud arrivals. They're quiet anomalies waiting to be noticed. See you next time.